All right, we're going to talk about the use of congruent triangles today. Basically, we've already talked about side, angle, side, angle, angle, side, angle, all those things, the 5 things that we can use to prove triangles congruent. But here's the deal. If I have triangle A over here, and I have triangle B over here, and I have a segment that's congruent to the same segment over here, and an angle that's congruent to the same angle over here, and a segment that's congruent to the same segment over here, are the 2 triangles congruent? Yes. Okay. Because of why? Side, angle, side. Okay. Now that I have triangle A and B congruent because of side, angle, side, what do I know about triangle A and B and everything in it? Yeah, everything has a congruent part, right? Between the 2 of them, they all have congruent parts. I don't have to prove every single thing to be congruent because now you telling me that this triangle is congruent to this triangle tells me that everything in there is congruent to something else, right? That's the concept that we're going to talk about today. So what we have to do is we have to find 3 things to prove the triangle congruent. Once we've proven that the triangle is congruent, then we know that all the parts are congruent. And then in our proofs, which we actually had to use on last night's homework a little bit, our proofs, we can now use a thing called CPCTC. Okay? Corresponding parts of congruent triangles are congruent. That's kind of common sense, right? But now you have something to write in that reason statement, the reason side. CPCTC. Okay? So that's what we're looking at. So when you do a proof and you've proven a triangle to be congruent, once you prove that triangle to be congruent, you can say, hey, this part now is congruent to this part because of CPCTC. Okay? Pretty simple. Everybody have that? Okay. Now, in order to use CPCTC, you must have the triangles proven to be congruent first. Okay? You can't just see that they're congruent and skip that step. You have to prove that they're congruent first. One of the things I've noticed about students when you're struggling with proofs, because not everybody, a lot of people are still struggling with proofs to a high extent, and that's because of a lot of different factors. But one of the main factors is you don't know your vocabulary. So you got to study that. And there's nothing I can do to help you with that as a teacher, unfortunately. That just comes down to you memorizing memorizing note cards, flashcards. Hey, this is what this means. And you have to know it so well that when you see it, you can automatically apply it. And know that it's the, congruent supplements theorem, or know that it's the reflexive property or whatever. I still have people that don't know that. We use that all the time. Okay? So you have to memorize those theorems. That's the big thing. And the other thing too is we skip steps. We try to skip steps. What people are going to want to do here is skip this triangle's congruency first. You've got to prove the triangles are congruent, and then you can use CPCTC. But you have to have that in your proof somewhere. Everybody have that? Okay? Just a little nugget of knowledge here to kind of help you with proofs with using CPCTC. The first thing you're going to do is obviously restate the given. Put that in there first. Once you have the given, then you're going to find 3 things to be congruent. You're going to find those 3 things in the triangle, whether it's using a segment congruent because of reflexive, or a segment's congruent because of the midpoint, definition of a midpoint, or 2 angles are congruent because of vertical angles. Whatever the case is, you're going to prove the 3 things to be congruent. Once you've proven those 2 things to be congruent, now you can prove the triangle is congruent using one of the 5 things: side, 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 angle, hypotenuse leg, and angle, side. Okay, those things will help you prove your triangles are congruent. Once you've done that, now you can say any part of the triangle, any 2 segments of the triangle that go together, corresponding segments go together, are congruent, or any corresponding angles are congruent based on CPCTC. Okay? Now again, please understand that they have to be corresponding parts, meaning that the same part in the same place in the triangle. Everybody follow that? You can't just say, oh, this part's congruent to that because of CPCTC. It's got to be A's here, A goes with D on this side, so A and D are congruent because of CPCTC. Yes? Yes. Bueno. Okay? Any questions so far? All right. Next, I want to kind of use this example right here. It's kind of silly. talking about the world's tiniest bull, okay? Because we're talking about a 5 centimeter or a 10 centimeter pin there. But what we want to do is we want to find out how wide the bull's pasture is, okay? So we want to find out how big his pen is. Now here's the deal about this bull, okay? We don't want to lose eye contact with the bull because the pen is not very secure. So if we take off the bull, he can run through the pen. So we don't want to get too close to the bull. So here's the fence right here, okay? And here's the fence over here. Those two parts of the fence. I want to know how long this is, okay? So the first thing I'm going to do is I'm going to find the midpoint of that fence, okay? I'm either going to stake it down or whatever, but I'm going to find the midpoint of that fence like this. So B right here is the midpoint of that fence. So since B is the midpoint of that fence, what do we know about A, B, and BC? Yeah, they're congruent, right? We know they're congruent because that's just the definition of a midpoint. Now, what does that line represent? That big long line? If that's the midpoint, what does that line represent? And I'm standing right here. This is me standing right here by E. What does that line represent?
Transversal.
Now, don't think geometrically. Think more realistic. Yes? Well, you see how that line goes through the pen? Do I want to go through the pen? No. What else could it be? What? Line of sight. That's exactly what I was going to say, Daniel. Okay, that's your line of sight. Like I told the other classes, I used to be in the Navy, and I was on submarines. And one of my jobs on the submarine was to track targets, to shoot them. I mean, that was what my job was. We didn't do it, but we could. And we would sit out there and we'd track targets, and we'd do a line of sight. Okay? And what I would do is, this is our boat right here. Here's another boat over here. It's got a certain angle of a line of sight and this and that. We do all these kind of mathematical calculations so that we can shoot a torpedo, if we needed to, at a boat, so that way it intercepted and blew up. So we use line of sights all the time. So that's what this is. This is saying, hey, I can see right here. Now I have peripheral, of course, but my direct line of sight is to the other part of that fence. Well, that doesn't help me if I'm just looking at the very beginning of the fence. So what I'm going to do to be safe is I'm going to walk away from I'm going to do a perpendicular path away from the fence. But what am I starting to see more of now? Yeah, I'm starting to see the other side of the fence, right? You ever done that before? You ever looked at something and then you started walking, you realize, wow, that's a lot longer than I thought it was. You keep walking, you keep seeing more. Keep walking, you keep seeing more. You keep walking, you keep seeing more. Like, well, that's never going to end. Okay? And so that's basically what we did. We just walked, and now we can see the other end of the fence. Okay? So now we can see the other end of the fence. Well, what did we just create? We just created two triangles. And so now our distance from the fence is 10 centimeters or 10 meters because we know that because we walked it, right? So we know how far it is away. We are now, at this point, guessing that this is 10 centimeters also. It seems logical, right? Your line of sight is directly in front of you. If you move 1 foot, it's going to go 1 foot. You move 1 foot, it's going to go another foot. That seems logical to me, right? Let's prove it, okay? So we're going to prove that that's 10 feet because if that's the case, what do we know about the pen? The width of the pen? It's 10 centimeters, feet, meters. That's a bad example for whatever. Okay? So, we have two triangles. What do we know about the two triangles? Okay, what? They're not congruent yet. We need to prove that. We can't just assume they're congruent.
One of those sides is 5.
So we have one congruent side. So we have the 5 centimeters. So that's a good start. What else do we know? We have to deduce now.
We know that the two angles.
Okay, give me a name of the angles.
ABD.
ABD
And EBC.
and EBC are,
They're congruent.
they're congruent because of why?
They're vertical.
They're vertical angles. Vertical angles congruency theorem tells me those two angles are congruent. That's good. What else do we know? Yes. Well, we don't know that. That's what we're proving. That's what we're trying to prove. Okay, she said EC is congruent to AD. We're trying to prove that right now. But what else do we know? Remember my path that I took. What did I tell you about the path that I took? It's a perpendicular path. So what does that mean about ECB?
Right.
It's a right angle. What else is a right angle? BAD, right? Because what kind of pen do we have? Square or rectangle. At this point, we don't really know. But in any case, it's at least a rectangle because a square is a rectangle. Okay, so we know that this is a right angle and this is a right angle. So what does that mean? They're congruent based on what? What? No. Why do we know those are congruent? Right angle theorem, right? Which says what? All right angles are congruent, right? If it's 90, it's 90. Now what do we have? We have our three things. Good. We have our three things. We have an angle and a side and another angle. So now we have angle, side, angle to do what? What does angle, side, angle do? Whoops. It proves that ECB and triangle FAB are congruent because of angle, side, angle. Now, is this side 10 centimeters? Is AF equal 10? Yes, based on what?
CPCTC.
Yeah, so EC is equal to AF based on CPCTC. And if EC is 10, that means AF is 10 as well. And again, that's just definition of congruence. Okay. Any questions on that? Yes.
If you're trying to prove that like angle E and F are congruent, use this CTC.
Yes. Okay, good question. She said now, if I want to prove that angle CEB is congruent to angle ADB, can I do that? Yes. Okay. Somebody said third angle congruence theorem, but I also can use CPCTC. Once I've proven those triangles are congruent, everything in there is congruent now. Everything. As long as it's matching sides. Okay? But you could use third angle theorem too as well. That would work as well. Any questions on that? All right, let me show you some real world, because one of the kids in last class, he goes, well, why would a farmer, which is not a farmer, okay, a rancher handles livestock, by the way, but he said, why would a farmer even do that? That's so stupid. Okay, and it is. It's just a kind of a juvenile scenario. Sorry about the lights, but it's kind of a juvenile scenario. But what we can do here is we can actually put this to a real world. This is a picture of where the new high school is going to be before it was built. Okay, now if you look here, this is Walnut Grove. Okay, I can drive down Walnut Grove, right? This right here is 1387. Now it's a straightened version of 1387, but that's what that is. Can I drive down that? So I can tell the distance here, I can tell the distance here. But here's property I can't get on. So I can't tell you the distance here. Here's property I can't get on. So I can't tell you the distance here either. But what I can do is I can keep driving. Whoops, wrong car. I can keep driving down Walnut Grove and have a line of sight. And I've driven off the map until now I see the end of the property. And essentially, I've created two triangles, which we just proved a second ago are going to be congruent, right? But I can prove the congruency, and based on that CPCTC, I can now use that to find out the distance of that property. Now, could I realistically do it from a car? No, I couldn't do it from the car, but I could do it from an aerial photograph, right? Is there anything that would keep me from doing that on a piece of paper? No, I could just take a picture and do exactly that right there. Okay, and that would help me. All right, so that's kind of a real-world application to that. Now, before we get into our work and all that, I want to go over a couple things, another example out of the textbook. So give me just a second.